All right, so in this video, we're going to go over how we're going to code the chi-square test for independence in RStudio. So I've uploaded the animal data set. I renamed it animal, all lowercase. So in order to run a chi-square test for independence, we first need to make a table that we're going to run the chi-square test on, right? So I like to always call my table two-way just because we have two variables that we're going to look at. Okay. You don't have to call it two-way. You can call it something else if you would like. But I call it two-way. And we want to compare the sex of the animal by the type of the animal. So if we go look at the sex of the animal is going to be male and female. And then animal type is dog and cat. Okay. So it doesn't matter what order you type the variables in. We just need to pay attention to what order we type them in, and I'll explain why that matters in a second. But it doesn't matter which order you type them. Just remember, and we'll have to come back to what order you typed them in just a sec. Um, so we created the two-way table, but if you notice, I don't see it anywhere, right? It says that I created a table over here. Here's its indexing. And then down here, it just repeats the code from up top. So remember that when we give something a name, we don't automatically get to see it, right? So if you want to see the object that you named, you need to ask for it. You need to ask R to show it to you. So we made a table called two-way. So if we want to see it, we need to ask for it. So we ask R, hey, show us two-way. So here's the table that we made. Okay. We're not really going to do anything with it. We're just saying this is the table. Okay. So let's say that instead of a regular table, we want a proportion table, right? So let's say for not the chi-square test for independence, but the probability section of the unit, where they ask what's the probability that of being a female cat or something. I know you can just divide, and that's not that hard to just divide. So this may seem useless, but remember we have really small data sets, and then like data analysis in the real world, you would have thousands and thousands, so you wouldn't want to divide 100 times. So this one line of code will turn the whole table into a table of proportions instead of having to do each one pieced out. Okay, but it's not hard. So we're going to give the table a name, and since it's a table of proportions, I like to call it prop. But remember, the names, you can technically call this whatever you want. So it's a table of proportions, so I call it prop. So here's the table. And what we're going to do is there's a prop.table command where it will take a regular table that you've already made and convert it to proportions. So the table that we've already made is called two-way. So that's how we're going to start the prop table code. And then this is where it gets weird. You can either put a 1 or a 2 right here. And this actually brings me to the notes document. So if you look at our week at a glance, it's at the top of Canvas. It's at the top of Canvas. So if you look at the week at a glance on Friday, here's the notes document. Okay. And later I'll link this video down here, but you'll already see that if you're watching this. So the notes document here, I leave you notes here trying to help because I'm not going to be there to physically speak this to you. Hopefully the video works, but this is written notes that can help. But basically, the difference of the 1 and the 2 is which variable do you want the proportions broken down by, right? So if we type a 1, we're going to say that we want the sex variable to be what we organize by. So the proportions of male would add up to 1 and the proportions of female would add up to 1. Okay. If I type a 2, I'm saying I want animal type to be what I categorize by or what my totals belong. So cat totals and dog totals would add up to 1. In the real world, you would decide this for yourself, which one you want. But a 1 is if you want to categorize by the first thing you typed in the table, which in my example would be the sex variable. And a 2 is if you want to categorize or make your totals by the second variable you type, which in mine would be animal type. Okay, in this case, both of the variables are 2, so it honestly doesn't matter. Generally, you want to categorize by the variable that has fewer categories. So like if gender had 2, but animal type had 6, we would want to categorize by sex. Okay, but since these are both 2, it doesn't matter. So I chose to categorize by animal type, so I'm going to put it 2. Again, the assignment will probably tell you, and if not, like on the practice or lab, you want to categorize or total up the variable with less categories. Okay, just generally speaking. So again, we made the table called prop, but it didn't show up. So I have to specifically ask R to show me the table called prop. So I have to type prop and run that in order to actually see my table. So here's my proportions. And if you look, we have like 48 and change, 51 and change. So cat adds up to 1, dog adds up to 1. But if you add this way, 51 plus 54 is over 1 because we didn't categorize by sex. We categorized by animal type. Okay. That's actually not the point of this coding, but they will ask on the lab, what's the proportion of this happening? So we do need to know how to do the proportions just so we can calculate that. So now we're going to make a bar plot, right? So with chi-squared and with tables, we make a table, and then we're going to make a bar plot. You can technically make the bar plot out of either of the tables we made, the prop or the two-way. But if you make your bar plot out of the prop table, all the height of every bar will be 1, so it'll look clean across the top. Every single one of your bars are the same height, broken down by proportion. This looks better than doing the two-way table where female cat would be 88, but male dog would be 160. So you're going to have all these various levels, so it's just not going to look as neat. So I like to use prop, but again, you technically can use two-way if you want. But the command for bar plot, we did this last unit, but it's bar plot. And then you do a bar plot of the table you want to use. So technically right here, this makes my bar plot. Okay, but remember that UT wants us to label our axis and make it pretty. Okay, so we need to add some extra things here to get full credit on our college lab exam. So the prop table is what we want. So we do bar plot of prop. Then we need to do main is my main title. And this is sex of animal by type, or whatever you want to call it. It doesn't matter. And then we're going to label our x-axis, which your x-axis is going to be what we categorize by, remember. So we did a 2 in prop table. So our x-axis is going to be animal type. Oops, I forgot my equal sign. And then because we are doing off the prop table, we want to make sure to label our y-axis proportion because it's not going to be frequencies, right? So you can technically do proportion or relative frequencies if you want to be fancy, but I prefer to just do proportions. Then we're going to add a couple new things that we didn't have last time. But remember, the labs are open notes, so just copy these notes down, and these things should always be a part of your bar plot. But we have legend equals T, which stands for true. And if you go back to your elementary and middle school days, a legend, sometimes it's called a key, but it's a color coded. It shows you what each color is, right? It's going to label the chart for us. So legend equals T, we're always going to need because that's going to give us a legend or a key on our graph. The last one, and this is the weird one, if you get an error code, I'll show you what you probably forgot. So it's called xlim, and it sets the width of our x-axis. And basically, it's how wide is the graph. So sometimes when we make our bar graph, I'll show you. I'm going to run it without it, but don't run it if you're following along with me. So see if we make our bar graph, you can see that my legend is covering up the bar. Now, to most of us, probably not a big deal. But imagine you're turning this report into your boss, right? And your legend is covering up your work. Okay. So what we can do is we can squeeze the graph. Okay. So it's called XLim. And the part we don't want to forget is there is a C here. If you look at my notes, you see it, but that's not a typo. So that's not a typo. Okay. So the XLim, that C is for a concatenate function. Like we're basically just going to set the parameters. So it's always going to be 0. And I'll just tell you this graph. Oops. 4.5 is a good limit. And then we need to double close here to close my table also. But so 4.5 is good, but the bigger. So now you can see the legend is not covering up my bars anymore, right? And the bigger the number, the more you're squeezing. So see how 2 made it worse. The bigger the number, the skinnier we're making it. So actually 3 works right here, right? So just kind of play around with this top number until, and you just hit run every time and it'll make a new graph for you, okay? So play with this top number a little bit until you can find something that looks nice. So actually 3 is kind of better than 4.5. I'll probably change my notes to have a 3 because this looks pretty good. Okay, so that's bar plot. So now we have our bar plot. And all we're going to say in our bar plot in our conclusion is you want to check to see if 2 variables are independent, the white or light gray and dark gray should be about equivalent across the board. Not that they're a 50-50 split, but the height of the dark gray should be about the same all the way across visually on the bar graph. Now we're going to run a chi-square test to check, which is visually on the bar graph. If we say that sex and animal type are independent, okay, we should, if we think sex and animal type are independent, then the height of female, which is dark gray, should be about the same on each type of animal, right? And in this case, looking at the graph, they are. They're not perfectly the same, but they look pretty close. So just looking at the bar graph, I'm going to guess that we're going to fail to reject the null and say they're independent. Now, we're going to run the chi-square check to see, but just looking at the graph, that would be my expectation. So to run the chi-square test, we need to do 2 things. We need to find our expected values and then run the chi-square test. Now, the expected values on your paper kind of sucked. The expected values on RStudio are super easy. So the command is called chi-square.test. So CHISQ.test. Then you want to tell it what table do we want to run a chi-squared test on. And we're done with the prop table now. But we want to run a chi-squared test on our 2-way table. Okay? So we want to run a chi-squared test on our 2-way table to see if these variables are independent. And we want to find expected, and this is not a typo. I put money sign expected outside of the parentheses on purpose. Okay? So when we run chi-squared test 2-way money sign expected, this is going to give us our 4 expected values. So here's our 4 expected values. And then here's our 4 observed values, right? So to find the chi-square test statistic, we would do 88 minus 84 squared over 84 plus blah, blah, blah. We would keep going, right? But ours can do this for us, so no worries. So to run the actual chi-square test, since we've checked the assumption of expected counts, we're making the expected counts in RStudio because we need to check the assumption that all of our expected counts are at least 5. So we have 84, 97, 135, 155. So in my conclusion, I would state all 4 of my expected counts are greater than 5, or at least 5. So all my expected counts were at least 5. So the assumption was met. Okay. But to run the actual chi-squared test, you do chi-squared.test. You tell it what table you want to run a chi-squared test on. And then we're going to always put something at the end, whether we technically need it or not. Just it's good practice. Okay. So correct equals true basically is helping us correct if our expected count isn't met. So we're just going to put that just in case so we don't forget because it's not actually going to affect our answers. So if our expected count is met, that's not really doing anything. If our expected count is not met, like let's say female cat was 3, which is less than 5, we would have a problem, but this correction would override it. Okay, so just always put the correction just in case you need it. It's just good practice to have it in there. When we run the chi-squared test, it's not going to give us very much. It's going to give us 3 things. It's going to give us the test statistic, which we will include in our conclusion, but we don't care because we're not going to find the critical value. Degrees of freedom, we will put that in our conclusion, but we actually don't care because, again, we are not finding the critical value. Then it gives me the p-value, which is what I do care about. So it's going to give me the p-value. And remember, we're comparing the p-value to 0.05. The p-value is the probability that the null is true. I mean, the probability that my study occurs. So the probability of this experiment happening, assuming the null is true. So a really, really small probability means we're going to reject the null and say it's not likely to be true. A high probability is saying that this experiment is likely to happen if the null is true. So a high probability is saying that the null is more likely than not to be true. We can't say that it is true because that's against the rules. But so with the p-value being 0.589, so 0.6, that's significantly higher than 0.05, right? That's way higher than 5%. So we're going to fail to reject the null, which means that sex and animal type are independent. Okay? So here's all the code. Again, go to the WAG, the week at a glance, and then go to the notes document. I try to type in extra notes just to be helpful since I'm not here. Okay? So go through the RStudio practice assignment and give it a shot. I'll try to respond to email, but email me if you need me.